This is our June 2003. This was the case when there were papers of only these practical papers were only of 1 hour and 15 minutes. But nowadays, there are two questions, and the time has been for 2 hours. So one question is for 1 hour, but still these practicals can do a lot. Now this let us see what he says in this question. He says in this question, you'll investigate how the period of oscillation of a bent metal wire varies with the angle between the straight parts of the wire. A wire will be given and we'll bend it, and we will see how its time period depends upon the angle between its two parts. Uh, Secure the cork in the clamp so that the pin is mounted horizontally. Make a sharp bend in the wire at the center. First of all, you should always measure its length. See what's the length of the. If you measure this length, I have to write just because you will notice that now I will uh, show you this thing. This length is, this L is, I can say, write it somewhere here. This L is 40.0 centimeters, or it is 0.400 meters. Now whatever I write with the black pen, that can be for the examiner, but whatever I write with the red pen, that will be for you. Now he says measure and record angle theta. Now I have seen some students measuring just record, just let me take the red pen first. I have seen the student taking this angle and they say this is not 160, but this is just not on the scale. You have to make this wire 160 and record it here. 160 degree with no decimal places. Why no decimal places? Because you have used the protector which has the least count of 1 degree. Now he says estimate the percentage uncertainty in the measurement of showing your reading. First of all, let us see if you can see when while we're doing the practical, you will see this wire is very much thick, so it occupies 2 degree from one side, 2 degree from other. So total uncertainty is 1 degree due to an instrument plus 4 degree that, and becomes this 5 degree. So absolute percentage, absolute uncertainty becomes 5 degree upon 160 multiplied by 100, and this will give to you. You can calculate 5 into 100 divided by 160. .125, so I can just write 3.1. I'll write it here, 3.12 percentage already written. So percentage uncertainty is this one. Now what the examiner will see, examiner will only see this, that you have taken the proper uncertainty or not. For example, what the examiner will see, this, check this one, this must be 5 degree, and this is 5 divided by your reading multiplied by 100, and this one, then he will give you this mark. What the next part he says? He says suspend the wire from the pin so that the arrangement is shown this one. Now arrangement should be this one. Displace the wire from its equilibrium position and release it so that it performs small oscillations. It will be oscillating like this one. It will be oscillating here and there. It will be oscillating like this one, and we have to find the time for one oscillation. So it is better to calculate time for 20 oscillations. Already we have recorded the reading. You can see I have written here 20t. 20t means time for 20 oscillations, and this has been recorded in 2 decimal places. This is in 2 also, and average has been taken. So it comes out to be 33 point, this one, sorry. You can see this is 33.11. See this one 2 decimal place. This must be correct, 4 significant figure. So T will be 33.11 divided by 20, and you can see T1 this one, this divided by 20, 33.1, it comes out to be 1.656 seconds. So 1.65 seconds the time period. Now it says remove the wire from the pin. Change the value of theta by gently bending the wire. The new values of theta should be in the range 160 degrees greater than equal to theta. He's giving a range. He's saying 160 degrees greater than equal to theta. Theta is greater than equal to 30 degree. Or it is basically the range between 30 and 60 degree. I can write also this way. So let us see which angles I will take. For formula for interval is maximum value. Maximum is 160 minus minimum value, which is 30, and divided by, always we have to take 6 set of readings, so we always divide by 5. Actually it is number of readings minus 1, so once it is 130 divided by 5, it comes out to be 28 degree. So interval is of 28 degree. Now which values I will take? See, but I will first take 160 degree, then 134, 134. No, it's not. It's 26 degree, not 28. Sorry. It's 26 degree. So then 160 minus 26, 134, then 108 degree, then you can have always the minus sign, so it is then 82 degree, then minus 26, also then it is 56 degree, and then 30 degree. You can see I will take this one, 1, 2, 3, 4, 5, 6 values, and I will take these angles for the measurement. And now rest goes to Fida Bhai. He will be showing you. I am very much thankful to Fida Bhai, to Sardar Zafarullah Korejo, my brothers Javed Khadim Pharero and Waqar Khadim Pharero, and also I am very much thankful to Shahid Awaz Bhai, who is providing me this these papers of the Cambridge on my laptop, so that I can handle them very easily. So thank you all of you, please. Now it is over to Fida Bhai for the reading and other things. Over to Fida Bhai. Fida Bhai is ready with his apparatus. Now first he will show us the angle with the protector. He is showing the angle. He is showing the angle. Yes, it is now 0 degree. You can see one arm is 0 degree, other is at 160 degree. Exactly, the angle is 160 degree. Okay, Fida Bhai. Okay, I am very much thankful for all technical help today in my studio. For technical help, Fida Bhai is here with me, Sardar Zafarullah Korejo, and my two brothers Javed Khadim Pharero and Waqar Khadim Pharero are also with me. Now he's oscillating. He will oscillate the things. It's very difficult for the first reading, but it's 160 degree.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. He is taking the reading after 20 oscillations. He is showing with the reading. It's coming 33, exact 33 seconds, but I will write 33.002 decimals is our must. Okay, Fida Bhai, 33.00. Yes, now he will repeat the reading at say 160 degree. 7,
He's counting also.
9, 10, 11,
12, 13, 14,
15, 16,
17, 18, 19, 20.
20.
Yes, Sudha, will show the reading. Very good, he's very much consistent now, 33.22 seconds. So it is 33.22 seconds the second reading. First was 33.00. Now he will change the angle and he will actually show us the angle also. Now he is actually showing the angle. Yes, he is showing the angle now. Angle must be 134. Yes, you can see it is 134. It is 134 degree. Yes, you can see it is 134. The one arm is 0, the other is 134. Okay, Pita bhai, you can oscillate the thing.
Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Thank you, Pita bhai. It is 134 degree, the first reading. Yes, it is 23 point. It is not 23.10. The reading is not clear. It is coming due to light. Yes, it's not clear. 23.10. Yes, 23.10 is the reading. Okay, now I will repeat this reading again.
Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Yes, Bhai. Yes, it's 22.78. Thank you, Bhai. Now Bhai will change the angle. Yes, Bhai is now has changed the angle and now it is how much? 108. Yes, it is 108 degree. Yes, okay. Carry on, Bhai. 108. You oscillate the wire.
Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20.
It's about the first reading at 108 degree. Yes, it is 18.84 seconds. Thank you, Bhai. Repeat it.
Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18,
19, 20. Yes, Bhai. What's the reading? Shabash. It is 18.06. Very good. Well done, Budawai. 106. Now he will change the angle, and he will change the angle. Yes, Budawai has changed the angle now. He will show the angle here. It is now, it must be at 82 degree now. Yes, it is 82 degree. Yes, it is 82 degree. Yes, Budawai, you have seen it. This is our fourth reading. We have taken at 160 degree, 134 degree, 108 degree.
Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Yes, Budawai. Yes, it is 16.90 seconds. Thank you, Budawai. Kindly repeat this reading.
Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20.
The reading is 17.06 seconds. Thank you very much, contestants. You are. Thank you. Now he will change the angle. Yes, now Budawai has changed its angle to 56 degree. Now he will be showing it here. Yes, you can see it is 56 degree. You can see it is 56. Yes, okay, it is 56. Okay, it's 56, okay. There is always an uncertainty in the angle. Because the wire is very too thick. It is oscillating.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20.
The reading is 15.44 seconds. Thank you. Kindly repeat it again for 56 degree.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20.
Yes, 20 is 15.38 seconds. Thank you. You are very much concerned, Budawai. Now the last reading, and he will be changing the angle. He is removing the wire. He is changing the angle. Yes, Budawai has now changed the angle at 30 degree. The last reading he will be showing us the reading at 30 degree. Yes, it is, as you can see, yes, it is exactly 30 degree, okay. Yes, Budawai, you can now oscillate it. That is our last reading.
Zero, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14,
50, 60, 70, 80, 90, 20. Yes, Budawai. 15.62 seconds. 15.62 14.62 seconds. Yes, Sudhabai.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20.
It's 14.90 seconds. I think once repeat this reading, because it was first 15.62, which is very much large difference. So I'm just repeating. I want to repeat this reading again. Just take another reading for this.
Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20.
Yes, Ramai. Show me the reading. Yes, now it is okay, 14.81. So I will not take the reading of 15.62. It's 14.81. I will take the two readings, 14.81 and 14.90, because there was some error in the reading when he took the 15.62. So I just changed it. Thank you, Fida Bhai. Thank you, Zafar Bhai. Thank you, Javed Bhai. And thank you, Wakar Bhai. I'm very much grateful to all of you for doing those technical help. Thank you. Thank you, Fida Bhai. Now Fida Bhai has taken the readings, and I have processed them also, the reading with the whatever the calculation is, because in order to save the timing. Now these were the calculations and these are the angles. First of all, let us see how these marks will be given. I'm just taking the red pen because the red pen is very much essential to take, so that you can have this thing always. The red pen, this one. You can see first theta is in degrees. First check the columns. Theta is in degrees, yes. Then 20t in seconds, just 20t1, 20t2, 20t average. Then t in seconds. Then I have to calculate actually 1 upon t power 4. Now in physics practicals, you cannot calculate directly. Now there are two choices. First you can calculate t, okay, t, then you can calculate t upon 4, then you can calculate 1 upon t4, or another t, 1 over t, and then you can calculate 1 upon t over 4. It's up to you. So I have given this the first t, then 1 upon t, then 1 over t and 4, and always you have to take the fresh data. That's always the rule, 1 upon t power 4, and see how I have written the units. 1 upon t power 4 slash s power minus 4. Now this is the slash and this is a horizontal line. You can see this is a horizontal line, and the cos theta have no units. So this is so now if this will be suppose the 4 marks first for the this one, then the column headings are okay. Then after column headings with the proper units, they will go to the decimal places for the range. The range must be actually he says the range must be 160 degree and 30 must be included both, and it must have equal interval of 26 degree. So we actually I taught you how to take the maximum minus minimum divided by 5, and you get this one. So now this is the range column, okay. Then you go for the decimal places. You can see because the angle was made with the protector, so no decimal place because it's a 1 degree. So you can see no decimal place there, here no decimal place, but there must be 2 decimal places in the seconds, and second must be repeated seconds. So you can see 2 decimal places in all cases. So then you get this mark also. Then 1 mark is on the calculation. Okay, 1 mark is on the calculation. Now we will check the calculation. Suppose I am checking, and always you will not carry the old things. Whatever you have written, you have to catch this one. I am just taking one thing here. The 4th line I am taking. Suppose this is 82. Okay, this is 16.90, and this is 17.06. Average of 16.90 plus 17.06 divided by 2, it comes out to be 16.98. Now 16.98 will be divided by 20. 16.98 divided by 20, and up to 4 significant figures, you are given 0.849. So make it 4 significant figures, 0.8490. Now I will take 1 upon t. 1 upon t of this one. So what will be 1 upon t? 1 upon 0.849, and this is in a 0. So this is 4 significant figure. So 1 upon t also should be in 4 significant figure, and it comes out to be 1.178. Then it's power 4, 1 upon power 4, and it comes out to be 1, and into 4 significant figure it is coming 1.926. Then cos theta, since you can see theta is in 2 significant figure, so cos 82 will also be in 2 significant figure, and cos 82 comes out to be 0.14. So that's the calculation is okay. Now significant figures, you can see the values of theta here. These values of theta are in 3 significant figure, so this value must be in 3 significant figure. This is also 3 cos theta, this is also 3, but this is in 2 significant figure. Now see, you can see these things now. These are 3 significant figure, so sorry, 2 significant figure. So you can see this will also be now in 2 significant figures. I told you for this one 2 significant figure, this also 2, this also 2 significant figure. And see about t, all the values of t are in 4 significant figure, so t is also in 4. If there were 3, we made them 4. For example, in this one it was 0. What I have calculated, this was 0.849, then I put up 0 from myself in order to get the 4 significant figures, so 0.8490, and you can see this one. Now what the question he says, he says justify the number of significant figures which you have given for cos theta. So since I have written the 2 values of theta, one are in 3 significant figure, other are 2. So whatever the values are in 3 significant figure, their cos will also be in 3 significant figure. And the values which are theta is in 2 significant figure, the value will be in also 2 significant figure. I have written that since values of theta are either in 3 significant figure or in 2 significant, hence values of cos theta are also in 3 or 4 significant figures. Then you have to find again another thing, but then you have to plot the graph first. Now when you go to the graph, let us see, first you will always have the on the x-axis. Now along the x-axis, that is the cos theta, we have the cos theta no units, and whenever the graph of cos theta and sin theta is always at minus and positive values are, you can start from the minimum also, but it is better to have always for the sine or cos start from -1. This is minus 0.75, minus 0.5, minus, this is always 2, minus 0.0, 0.25, 0.5, 0.751. It's up to you if you work with your own scale method, which I told you, but please you have to keep the consistent, you have to be consistent with the sign convention. These are the negative values, and you can see for the positive values, and see I have written this here, since this was 0.25 for one big box, so I wrote here the value of one small box, which is 0.025. Now let us see how will I take the scale along x-axis. Y x-axis scale is fixed. If it's a cos theta or sin theta, you should always go from -1. That's the rule. -1 to +1. -1 to +1, and the interval is 0.25 taken. As you can take 0. For small value 0.025 for one small box. Now for the x-axis, y-axis, you can see now for the y-axis. Now y-axis can be started from the middle, because 0 is middle. You can start from the left also if you wish. Then this will be the false origin. See, this is also the false origin, but it starts from 0. The minimum value is I'm going to the table. Yes, this one. You can see the minimum of cos theta 1 is along for this one. You can see it's 1 upon t power 4 along y-axis. This value that is in the second column, you can see this one. The minimum is 0.1330. Minimum is 0.1330 and maximum, you can see the minimum value is 0.1330 and the maximum is 3.282. So let us see what the scale should be. If you go to the scale for this y-axis, see for x-axis this was the scale and 0.025 is written. Now let us see what should be the scale. I am taking the red pen again to show the scaling work here. See, scale is always for y-axis maximum. Maximum is 3.282. Maximum is 3.282 minus 0.1330 अपॉन 12 बिग बॉक्सेस हैं. तो देखिए स्केल क्या आता है 3.282 3.282 minus 0.1330 divided by 12. ये आ रहा है 0.262 0.262 का मकसद that's 0.262 means we have to take the numbers. The numbers are from 1, 2, 3, 4, 5, 6, 7. Sorry, these are the continuous numbers. I am talking about the numbers which I can take as a scale. I'm sorry. So let us see what numbers can be taken as a scale. Actually, this is in whole number it will be 262. Now I want to locate where the 262 lies. For scaling, this scaling should be 1, 2, 4, 5, then 20, after 5 10, 10, 20, 25, 40, 50, 100, 200, 400. You can see it's 262. So after 262, the number is 400, and if you 400, if can be made into decimal places, the value is coming to 0.4. 0.400 0.4. So 0.4 is a scale. So now you can take 0.133. So 0.133 and plus 0.4. You will number this 0.535 and so on and so forth. So this was how the scale was set for the y-axis. I have written here for this y-axis. This is the 0.04 for one small box. Now how I will point here? I will tell you to actually plot the point for 2 points because the negative points are involved also there. So suppose one positive point and one negative point I will plot. These points were this one. You can see for I'm just plotting one is suppose minus 0.695 and 0.577 1 point. Other point suppose I am plotting 0.56 and 2.839. So see, I'm just plotting the serial number 2 point and serial number 5 point. I have selected 2 points here because there can be something difficult here. This is a difficult graph actually. Let us see here. I am working now. How will I work? First is I have to plot a graph of minus 0.695 and 0.5777. So let us see where the minus 0.69 is and how I'll plot this. You know already the formula for the reading. It is the formula is reading whatever reading minus initial value divided by scale of one small box. So reading is minus 0.695 minus initial value is minus 1 upon scale of small box is 0.025. So this will be minus 0.695. It will be plus 1 upon 0.025. So let us see how much it comes out to be. If you plot, you can have minus 0.695 plus 1 divided by 0.025. It is coming 12.2 boxes, so I will take 12 boxes. 12 boxes along x-axis will be 12 boxes initially, 12 boxes along x-axis. Then there's a 12 box along x-axis. Then I will actually we will see. I'm just getting rid of these things first so that I can write another thing also. This for making you understand the thing. So I found for that thing that there are 12 boxes along x-axis. Now I'll find here the how many boxes I need here for y-axis, and for y-axis see how it is. If the graph starts from 0.133, so it should be 0.133. But what's the reading? The reading 0.577. So 0.5777 minus 0.1330 divided by scale of small box, this one 0.04. So it comes out to be 0.577 minus 0.133 divided by 0.04. It's coming 11.11 means 11.11 means what? I can write just it's 11.11 boxes. So just nothing but 11 boxes. Now you can see I'll count 12 boxes here. These are 10. You can see this one 11, this 12. 12 here along x-axis, 11 this one along y-axis. So this is the point, and this point has been encircled. So similarly this 1 point. Let us go for the other point. Other point, you can start from minus 1 or from 0. It's up to you. For example, other point is a positive point 0.56 and 2.839. I will take 0.56 first along x-axis. I'm just taking for 0.56 along the x-axis. You can say what's the reading? Reading 0.56 minus initial minus 1 upon 0.025. So it will be 0.56 plus 1 upon 0.025. It will come the number of boxes 0.56 plus 1 divided by 0.025. It's coming 62 point something, 62 boxes, 62 point it's unclear my calculator, but 62 boxes are there. So 62 boxes somewhere there. Then see I can go for this one 56. See this one 56. This will be 10, 20, 30, 40, 50, and then 62, 50, 60, and these are the 60. This is sorry, this one. These are the 66 boxes. 66 62 boxes. These are 60. You can see count again. 10. I made a counting mistake. 10, 20, 30, 40, 50, 60 boxes are up here at 62.22. 60 and 2 boxes further. 2 boxes further. So this will be the point if you count. And for the y-axis, you can also calculate. So you will plot the points in that way. Now, for how I will go for the line of best fit, I am showing you all these points will be encircled, and you have to go for the line of best fit. Let us see. I want to show it to you on a small scale how the line of best fit should be plotted. This one. See, this one point is below, this is up, this is below, this is up, and these two are so 2 up points and 2 down points. Then I have taken this one triangle for the gradient. See, this one, these are exact. I have drawn this triangle. Should draw a dotted line. I have drawn with the red pen. This is these are the 50 boxes, and these are the 55 boxes. And for the y-intercept, I will either read this value, because this clearly y-intercept. This value is you can see this value is for y-axis. For y-intercept directly, you can have this one. See, these are actually 0.133 plus, these are actually 2 boxes up. So it is 1.733 and 1.733. So it is 0 and comma 1.833. 0.1733 plus, there are 2 boxes, and 2 multiplied by 0.04. See, if 2 multiplied by 0.04, it is 0.08, and already this value is 1.733. So 1.733 plus 0.08, it comes out to be first for y-axis, this point is 0 and comma 1.833. This gives me the y-intercept. So I'm now going to the for the gradient and other things. Let us see. This is the gradient. A gradient is delta y upon delta x. There were 55 boxes along y-axis and 50 along x-axis. So 55 multiplied by 0.04, and then the 50 multiplied by 0.025 comes 1.76. So gradient is 1.76, and directly we have calculated the y-intercept is 1.833, and then this for the y-intercept, x-intercept. Then he says, this one you can see, he's given here. The equation is 1 upon t power 4 is equal to a cos theta plus b. So clearly this is y-axis and this is x-axis. So gradient is a and this is y-intercept b. So gradient is a 1.76 and this is 1.833, and the unit of a, you can see this one. See, units of a cos theta is units of 1 upon t power 4. So units of a cos theta is no unit, but you will write 1. So unit of a into a is s power minus 4. So unit of a will be s power minus 4. So the unit of a is s power minus 4, and unit of this theta, units of b will be units of 1 upon t power 4. So it's s power minus 4, the units, this one. So these the two values and the units s power minus 4. Now he says a theoretical treatment of this oscillator shows that a is like this. A is equal to 1 upon 2 3g upon 4 pi square into whole square, and put these values. Actually you have to put here L is 40 centimeters or 0.400 meter, and this is the gradient. Is just the value of is 1.76 in this one, and you can calculate manually this and calculate g square is coming to this one, and so the value of g is coming out to be very good. Shabash, very well done. 9.88 meter per second square. So that's very much accurate value. So you will get this all these marks for the value of g, calculation, other things. So that is actually we can do in practical this way and see the calculation also in this way.